when you turn this video off, then please tell me what the reason for it was so that I can improve. Otherwise, hi and welcome. I'm trying to learn physics today, how light behaves, and after we've done it, we're going to do squat training. And if you participate in the squat training, then it's at your own risk. And this is now part 4 for 5 of light in total, or how light behaves. Now we're having here the basic properties of light, and I'm trying to read and try to understand it. The basic properties of light. The way the eye perceives objects depends on the way light interacts with the material of which they are made. Okay, the way the eye sees something depends on out of what material the thing is made onto which the light comes. So, onto what it depends. The eye sees the things, not how the lights, not the light, but it depends on what object it falls upon, the color of it. Humans don't see the light itself, maybe as brightness. If we're meaning now what color the light has depends on what color the object has on which the light falls. And that has to do with the material out of which the object is. A flat surface reflects all the light falling on it at the same angle from the perpendicular at which the light strikes it. The eye sees a white surface. I don't know what the perpendicular is. Is that a part of the eye maybe? But it's not that important. If it is a flat surface, then the light just is reflected completely and it appears white. A flat surface appears white. Scattering. A rough surface scatters light because each part of the surface reflects the light at a different angle. The object appears dull or matte to the eye. Okay, a rough surface looks dull. It makes sense. A flat surface white, a rough surface dull. Now is the explanation why it is dark, that it is not completely flat, or is there another cause? Let's see it. Absorption. Some surfaces absorb more of the light falling on them than others. If light of all colors is absorbed, the eye sees black. Okay, we're saying so that it appears as a dark color, as a white color, has not just to do with that the one reflects and the other one absorbs, but it has also something to do that some surfaces absorb it. We don't know the reason of it. This does obviously not absorb the light, it is white, and that not. They are both not flat surfaces. That was part of the introduction. The way the eye perceives objects depends on the way light interacts with the material of which they are made. Light falling on an object can be reflected, scattered, absorbed, or refracted, or all four may occur. An object's color is determined by the part of the spectrum that it reflects and does not observe. Okay. We had it in the previous part. Light at different spectrums. Now light is just light. I don't know, it's no light. But now the thing is, if you have a prism, we had it written, with a prism, if you split it into the different parts of it, it's like a rainbow. You see, like in a rainbow the sun comes onto these raindrops and is split, something like that. And you see now the red, blue, green, whatever. And that are the actual colors of the light. Now the thing is, all these colors mixed together, so not opened in a rainbow, but all together as white light, enter something, an object. And now, this object seems to absorb all the red of the rainbow, all the red colors, the green colors, but not the blue, grey or whatever colors. So the blue and grey comes back, the red not. And that is why the thing appears grey, but the other reason was also that it maybe not the observation. It is all the observation. And this can't be really the reason that it's reflecting it. That is not really reflecting it. I don't think so. Maybe a little. But it is probably right because this thing seems to not to absorb these colors, but gives them back, but not because it's flat, but because that this material does not absorb them. It seems to give all back, so it appears again pretty white. It gives not just red back, it appears red, or blue, or green. It gives all these 4 or 5 colors at the same time back, and all together are again white. That is what I get so far. Refraction. The path of light ray is bent towards the perpendicular. It would be good to know what the perpendicular is. The path of light ray is bent towards the perpendicular as it passes from a medium such as air to a denser medium such as glass. It is bent from the perpendicular as it re-enters the less dense medium. Okay, I don't really get it. They are explaining what happens when light goes through glass. It seems to have still its normal colors. You can see through glass, but it might be a little bit refracted. I don't know what the word refracted means, or what the word perpendicular means, or what they want to tell us now, because it comes out at the other end with the same color. Maybe we're going to mean it passes through it, but not completely through it. I think that is what I mean. By me, they are explaining something where the light passes through it, but you still can see it because it is reflecting it. If you look at this graph, maybe they mean the thing. If it would pass completely straight through it, like through air, you would not be able to see the glass. But because the glass is not completely straight, or because the light comes from the side, you can see it, that there is something which is taking the light a bit to the side. You can still look through it, but not perfectly. I don't know, but that could be an interesting explanation why you can't see through some glass. Maybe there's then intentionally some things in the middle that you can't see through. And maybe that is an explanation why sometimes it is very difficult to see glass, and at other times it's very easier. And not just because they're clean, but maybe it is from the angle on which the sun or the light shines on it. It would be interesting, I don't know it, but it would be interesting if there's a lamp coming directly onto it and the light passes then straight through the glass, if you then see the glass very hardly. Otherwise, if it comes from the side, more. It would make sense. You see it when in the glass. There's mirroring of the sun. I don't know, but maybe you should pay attention to it. Maybe we'll find it out even if it's nowhere written. Just by observation. Dispersion of white light. White light, when passed through a glass prism, is split into the colors of the spectrum. This is because each color has its own wavelength, which determines the angle at which the light is refracted. Red is the refracted least, violet most. What they're explaining here, they have in a prism, so like a pyramid. And the thing of the pyramid is that it goes not to the sides in the same length. Now, if something comes into the pyramid and passes, not now through that here, through the lower end, it has a long way to pass through. If sunlight, no, it's refracted, but sunlight comes here, so I don't really get it. Now, one thing has the light itself has a shorter wavelength. Whatever, for some reason, either because the path is shorter, but it's because the light has a shorter length. No, I don't understand. It comes in, and why does it? Whatever. The point is, some light passes more straight through, others shorter, and that makes it that it does not come out at the same point, but it's split, and because they don't come out at the same point or something, they are now splitted, and that's because they are splitted. You can see now the different colors. Instead of white light, you see red, green, whatever, the whole rainbow. White light, when passed through a glass prism, is split into the colors of the spectrum. This is because each color has its own wavelength, which determines the angle at which the light is refracted. Why does the angle change if it comes with a different length? It comes long in, it continues, but a shorter one not. Why not? Okay, we don't really understand why, but we have it so far. Okay, we have a reflection. Some surfaces just reflecting completely the surface, it appears white. Other ones are scattering light. They are rough and they are now dark because the light is completely scattering. Some areas absorb colors, or at least some colors, and if all absorbed, then it's black because no color comes back. That makes sense. If there's no light, then it's dark. So if all the light is absorbed, then it's dark. And if it's just the other one absorbed, then less. And it depends on what type of material the light falls on, what light is absorbed and what comes back. And the refraction, I understand it that way, it passes through, but it's a bit to the side so that you are able to see a glass window, but the light passes still through. And dispersion, that is now, the light comes in, but some of the lights are longer than the other ones. And that makes them now, because they're going through such a triangle, because we don't have this, I don't really get it. Whatever, it is now split up for some reason. And that makes it, we are split up and now you see the rainbow colors. That was the physics part. If you're here for physics, you can go directly to the next part of physics where we're going to do the proof that light travels in waves. So if you stay here and participate in the squat training, and it's with your own risk. We bring one leg up, we're stretching a bit. One leg up, toes down. Other leg up, toes down. Now, legs wide apart, and we're doing 12 squats. So first one down and up, and the second one down, and the third one. And let's do the fourth and fifth one. And the 6, and now 7, 8, and now 9, and 10, and just 2 more, 11, and 12. And now, the fastest G-Rock, no. The 6-back squat squeeze. We're having the legs wide apart, we come down into quarter squat, and we're pressing against the top of the leg. And on the other side. Down into half squat, and press against the middle of the leg. And on the other side. Now down into 3/4 squat, and press close to the knee. And on the other side. Up again. And now the fastest giraffe of a waterfall. Down into 3/4 squat, press against the leg. And go towards it. On the other side. Press against the leg. And go towards it again. Press. Go towards it again. Press. And go towards it. One more round. And again. And up. Already the last exercise. The propeller. Down into foot squat. Arms to the side. Over to one side. Press against the leg. Look up to the head. To the middle. Over to the other side. Press against the leg. Look up to the head. Back again. And a bit stretching again. One leg up. Pull the leg up. Point with the toes down. Relax the leg. Other leg. Pull the leg up. Point with the toes down. Relax the leg. Make a straight back, point the knee down to the ground. Other leg, take the leg at the ankle, make a straight back, and point the knee down to the ground. Legs wide apart, breathing out down. And breathing out. In and up. Out and down. Breathing in, close the legs. And breathing out. That was a squat training. I thank you very much, and until next time.